Thank you, Benjamin, for joining us, the CTO for Elastisense. We're going to go through a short presentation just on some real basics around the Elastisense, and then I'm going to hand over to Laura and Benjamin. Laura's our coordinator at Dyna-mo, and she's going to pose some interesting questions that we've had around the Elastisense, which cover some of the more obscure parameters, the applications, some of the less common uses, and hopefully to clarify exactly what it is that the DS sensor does. There's been some confusion, shall we say, about some of the language around the sensor that we're keen to clear up. So the most important thing about the DS sensor is that it is flexible. So we're talking about a device that we can measure distance displacement, positive and negative, but the really key thing about the Elastisense is that it is a completely flexible device. So we're not tied to the absolute linear installation that we are with LVDTs or with crack gauges. There can be a quite considerable displacement on more than one axis, and the Elastisense can still be very easily installed and can still continue to provide very high accuracy readings on the positive and negative movement of the structures. It's IP68 sealed. We'll cover a little bit more about the ability for the sensor to perform in more extreme conditions. And it has no moving parts. Now, those two together means that we've got no issues with dirt ingress. We have no issue with degreasing. There's no maintenance of this, using it from one project to another. It really is a device that can be deployed multiple times very, very quickly. You can see that there are just two fixing holes on the device. There is an option to have two fixing holes at either end, but again, we're still looking at a very, very quick deployment and no need for on-site calibration or any technical knowledge to install this on site. It's a very simple device to install. The device itself is dynamic. We will again come back to that point. It's a really key question about not what the sensor can do, but how we can capture the data from the sensor. And that's really important because the sensor itself is effectively a dumb device. On its own, it really doesn't do anything. It needs a power feed and it needs an ability to communicate its readings to another device, whether that's to then communicate that ongoing or to log the data. I mentioned already, it's completely reusable, so for multiple projects, and has a very long lifespan, which we'll cover in more detail. And in terms of applications, there's a very wide array of applications that the sensor can be used for, whether it's looking at structural cracks, movements, displacement between two elements, a vibrational displacement. We've already mentioned the fact that this has a 1 kilohertz output, so we can monitor a very fast rate of movement, dynamic displacement. So similar to the vibration of a trampoline, would be able to detect how fast and how far that sensor is, so that surface is moving in a positive and negative direction. It provides an alternative, a perfect alternative to an LVDT, where we do have the issues of the need for a linear installation. We have challenges around dirt ingress, degreasing, and technical knowledge for installing those. All of those disappear with using the DS sensor or a crack gauge, just a very simple installation to monitor crack movement, again, positive and negative. And there are an array of options with regards to cable length, output, and additional options of color, and a whole variety of other exceptions that can be set so that we can provide the right product that's required for the specific application. So there are 5 variants available, and we'll cover specifically what those dimensions mean, because there is a separation or a difference between how an LVDT is generally described and how a DS sensor is described. But they're available in 5mm, 20, 50, 100, and 250mm variants. So if we then talk about the accuracy, we've got a very, very high accuracy of 0.5% full scale. We can operate from -40 to +85, and that can be expanded further with one of the options that's available as a variant. At maximum displacement, the sensor can deal with 120 Newton force, so we're able to put it in very challenging environments and it still perform without failure. And most importantly, it can be integrated with both wired and wireless data loggers. So on the wireless side, the DS sensor will work with a Wisen system, a move solution system, an Axio system, a wide sensing system, a Trimble system, a Monit system. It's been integrated with a device called the iBridge, and any other data logger that can accept one of the variety of outputs that the sensor is able to provide. And those are an analog output, so that's in 0.5, 0.10, 420 milliamp, or digital. Sorry, the analog, that's it for the analog side. And then in digital, in RS-232 and RS-485. And it is a very, very simple connection. We've got a simple example here of the analog connection where we have power feed out to the sensor. We have the ground wire returning. We have the signal ground wire connected to the same terminal. And then we have our signal coming back from the sensor. And the connection is that simple. It is a very, very simple integration to capture data. And why are we partnering with Elastisense? Well, we're one of their distribution partners specifically for UK and Ireland. We develop and supply remote monitoring systems, sensors, sensor integration, off-grid power conversion, installation accessories. So as I mentioned earlier, the sensor itself is effectively a dumb sensor. It does very little on its own. It requires the integration into a data logging or data communication system. And that's where we come in partnership with Elastisense to make sure the clients get the best method to retrieve the data, whether that be static monitoring at a very slow rate, reading once a day, 15 minutes, half an hour, as frequently as required, but a very static reading, all the way through into dynamic monitoring up to 1,000 hertz, looking at the very fast movement of structures.
Traditionally, a strain gauge is a sensor or a device that measures strain on any given substrate. It's typically steel or concrete or other plastic surfaces. So they measure a very tiny, should we call it, movement on a very tiny area. So either they measure the direct strain, or often it's converted into force. That's how they make loaders, for example, typically. So that's why this technology is very different. We have here a polymer. It's a silicone that you can stretch a lot. Typical strain gauge is maybe up to a few percent. Then you are almost overstretching them. That's where we start. So we can measure up to 100% easily if we like to do that. But the DS sensor is a displacement sensor. It measures a change in length, and that we typically talk about in millimeters, not in percentage of strain. So we talk about millimeters of things. I typically call this an electrical ruler. So yeah, we measure millimeters. Of course, this is represented in the analog output as a voltage or as a current, but it's typically millimeters. Yeah, that's a question of definition. As you just said, the LVDTs are typically given as plus minus 25 or 50 millimeters because it corresponds to their analog output that is typically plus minus 5 volt or plus minus 10 volt. The DS sensors are currently only providing 0 to 5 volt or 0 to 10 volt output, no plus minus, and then in the current version 4 to 20 milliamps. So we do not work with the plus minus thing, but when you're using it in a given application and you want it to be able to give plus minus, you should configure the DS100 sensor, which gives you a 100 millimeter measurement range. Set it in the middle position. So let's say you started at the 50 millimeter position, and now it can give you a plus minus 50 millimeter reading. But this means that on the output side, if it's a 10 volt sensor, you will start by setting the sensor at the 5 volt output and go minus down to 0 volt and plus up to 10 volt. I hope that makes sense. Yeah, that is typically limited by the data logger or node that is obtaining the data. So as Toby said earlier, the sensor is just dumb. I do not like that term because typically we call it intelligent rubber, but I get it. It's a dumb sensor. It doesn't do anything itself. It just provides its position in its output. And we measured at 2 kilohertz, but provide that in the output with 1 kilohertz. So if you're able to measure that fast, then you can see dynamical changes fairly fast. With that said, we also use a filter in the sensor, which is typically set to a value that filters over 5 milliseconds. So standard, it's limited to around a 200 hertz signal. So this then means that you can see very fast dynamic changes. Should a given application need even faster, yeah, then we can change the filter down to nothing, to 1, such that you can see up to a 1 kilohertz true signal. And I would say that typically you would like that your measurement system is 10 times faster than what you actually see. So that means if you have a thing that is moving with 100 hertz dynamically from with the full amplitude, this we are then able to look at. It surely does, yes. So when we developed the sensor, we had to start somewhere, and we agreed that we want to show that it's also useful in water. So what we've done is to test the sensor in a bucket of 1 meter of water for 1 full day. That means 24 hours. That's what the IP68 rating means. With that said, we have had it in water for longer times and it works fine, but it does not mean that it will not work at lower depths. We have just not tested this sensor for it. But I'm confident that our sensor can work down to 10, 50, 100 meters. I'm not sure where the limit is. I cannot see what should really limit what should happen to this dumb sensor, which is just a piece of silicone. So yes, it works in submerged conditions, and salt water will not hurt it. So that's also fine. The only thing that is worth noting is that when used in offshore conditions with salt water, that maybe does things to the standard housing, which is in aluminium. But then we also have a stainless steel version, which I will recommend for offshore applications. But the sensor itself will work fine. And another note on the IP rating is that also covers the washing of it with what is called high pressure water. You can do that also. That is also tested that you can wash it down with high pressure water, also at a high temperature. So that means that we could rate it to the IP69X or whatever it's called, but we have not done that properly. So that's a certification thing we are still missing to do. So yeah, as many times you want to mount it on something unmounted and mount something else, you can continue to do that as long as you want. The thing that limits its lifespan is mainly on its dynamical movements. So we promise 1 million cycles where you move it from 0 to maximum sturts or displacement 1 million times. So if you do that, 500,000 in the first application, and then have another 500,000 before we do not promise anything else. But typically in the space we are in here, we talk about static application where it's installed on a bridge. And if you have it installed for 1 year on one bridge, take it down, you can install it on another bridge, and you can continue with this as long as you want, we think. But keep in mind, we have to be honest here, it's a very young technology and a young product. It's from 2021. So we have not had installations in the field for 10 years yet. So let's see how that goes. That's one of the tougher questions. For what we have been selling to so far is in the structural health monitoring application. So bridges, crack monitoring, tunnels, dams, That is what we've seen most of, but we are also starting getting into the what do you call them, the heavy vehicles segment, where they are measuring on heavy vehicles, and then a little bit in the factory automation space also, where it's monitoring on machines, for example on metal stamping. We can come into that a little bit later. Yeah, that I have to be honest, I haven't seen them yet. I know there will be many, but some of the more interesting has been uh, some are using the sensors for a piece of machinery that are making elements out of concrete for building, but where it, due to high vibrations, have problems using other sensors. So the DS sensors we use for monitoring this machine that does stuff while making concrete elements. Yeah, then it's used for mining. It's used on trucks and trailers. Yeah.
That's great, thank you. Yes, so what I wanted to do, just in case some people hadn't physically seen the DS sensor be stretched and moved, we talk about the fact that it doesn't need to be installed in an absolute linear position. And I think it's really important to show, the sensor, its flexibility. There's lots of pictures of how the DS sensor flexes. Yes, of course, installing it at such an obscure angle would massively affect the sensor's performance. But when we're talking about it not needing to be installed in a linear position, we can take it as an offset on its direct installation, and also so on both on its X and its Y axis, we can have, and on its Z axis, we can have a displacement. Now, the further the sensor is installed displaced, the more the accuracy drops. But as we begin with a 0.5% full-scale accuracy, we are not compromising a significant amount of accuracy for this sensor to be installed where it wouldn't physically be possible to install a standard LVDT or a crack gauge. And we found that personally with some of the installations we've already had, where it would have been almost physically impossible to install an alternative sensor for two reasons. Firstly, the actual location for the fixing points at either end was very questionable. It wasn't flat, very corroded steel bridges and corroded concrete and tarmac surfaces. Where actually bolting very much deep through the steel and very deep into the concrete was the only way to get a secure fixing. And that meant that as we tensioned the fixings, we actually distorted the sensor fixings to some degree. Anyway, it was unavoidable. But this still maintained a very high accuracy of reading that we were able to validate, as we had 4 reading points across the same bridge, and we were seeing very similar and balanced behavior. As we were seeing one side of a bridge contract, we were seeing the other side expanding, and vice versa, and they were moving in very clear symmetry in terms of both the relationship and the scale. So it's one of the very unique natures of the sensor, which, with the confusion over it being a strain gauge, is really important to clarify that there are flexible strain gauges which can be installed in this manner, but this is absolutely a displacement sensor. But it overcomes a number of the challenges that are presented when trying to install in more challenging positions. Extending over further lengths. We've had projects where this has been proposed and installed as an extensometer, using 2-3 meter aluminium rods to extend from one end of the sensor to a fixed position, whether that be the cap or the base anchor. That there really is very little that limits how the sensor can be installed. There's a huge amount of flexibility in terms of its anchoring, and the really key element is that we have a degree of single axis movement which won't exceed the sensor's maximum range. And as Benjamin touched on, to install to get the plus or minus, we simply extend the sensor to its halfway position. So this being a 100 mil sensor in its relaxed position, to get a plus and minus reading, we would purely mark and extend the sensor to 50 millimeters at install. Now we have a minus reading of 50 mil, and we have a positive reading of 50 mil, giving us that plus minus range for the sensor. So it is very, very easy to install the sensor, whether it be looking at a single directional change. Equally, we could look at a negative movement only, so we could extend the sensor to its full scale and then only watch as the contraction happened of the sensor. So it provides a significant amount of flexibility in terms of how it's installed and how we want to use that behavior.
Often we are asked from customers, now your sensor can move in multiple directions. can it also tell me these multiple directions? And the simple answer is first no, because the answer is measuring, you can say, the distance in between the two mounting points, more or less. So if you want to then resolve the maybe X, Y, and Z movement, yeah, then you just need to add 2 or 3 sensors for 2 or 3 dimensions. If you do that, then we can resolve all 3 dimensions and get a very accurate result. Then we are back to geometry and do the math. Yeah, I would say no. The sensor are calibrated both temperature-wise and position-wise at our factory. But then we are back to, if the sensor has been through a dynamic application with a lot of cycles, that will maybe change, typically predominantly the offset slightly. But in most applications, you do not care about the offset. That is something you just remove while you set the sensor in its initial position. But if the sensor has been in a dynamic application over many cycles, then it might need a recalibration, but typically no.
So we're talking about the far greater cycle rate. So anything that is effectively a structural movement, we're unlikely to see anything that would require that recalibration. It would be something more like if we were monitoring the displacement between a track position and a bridge sleeper, and we were seeing constant, significant both extension and contraction of the sensor, that then over a period of time that would start to degrade the accuracy of the sensor. But that's quite an exceptional application.
It is typically so that when used for measuring something and you pay for it, whatever you like to call it, then there is rules and regulations that tell you that your sensors need to be recalibrated, typically yearly. That might dictate that the sensor needs to be recalibrated, but I do not think they actually need it.
We've seen a lot of interest in the sensor. We're seeing a growing desire to have a sensor which is very easy to install, easy to reuse, and I think the ability to purchase an asset as opposed to a project-specific cost is growing within the remote monitoring market. Certainly, we're seeing it with regards to the hardware, the comms itself. That the cost of a remote monitoring system is becoming less and less attributed specifically to one project and becoming more of an asset that is purchased like a total station or a GNSS unit. And the ability for some of the sensors that can be integrated into those systems, Elastisense being a prime example, to be equally reusable on more than one project is of enormous value.
If you stumble upon projects where the standard sensors will need a smaller customizations, just let us know, because that's also something we do. And Toby will for sure help you with whatever is needed. We can do everything normally.
That's perfect. Thank you, Benjamin. Thank you for joining us. So we have the fuller range of the Elastisense DS sensors available. So we, as a standard, generally offer the 420 milliamp, but we have both the 0.5, the 0.10, and the RS 232 and 485 models available. You can buy as few as one, and then multiple quantities. If it's in big scale, please speak to us, and we'll talk to Benjamin, look at specific support for larger scale projects. So if there are any questions about specific variants, if you can't find the information that you want, please get in touch with either Elastisense directly or us at Dyna-mo, and we'll help you out. And we can also support with specific proposals for site projects and the integration and connection of those sensors as well.